part of today's lesson, today's tutorial, why I say I want us to be very, very attentive. I want us to pay great attention. Let's take the question. And the question says, what quantity of heat will be necessary? What quantity of heat will be necessary to change 2 kilograms of ice to water at 10 degrees Celsius? At 10 degrees Celsius, they give us specific latent heat of fusion of ice as 3.36 times 10 raised to power 5 joule kilogram per 1, and specific heat capacity of water is equals to 4200 joule kilogram Kelvin per 1. So we start. I want to explain the question a little bit. The last question we treated asked us what quantity of heat will be needed that will be necessary to melt 2 kilograms of ice to water at the same temperature. Okay, this question is asking us almost the same thing. What quantity of heat will be necessary to change 2 kilograms of ice? This one is not at the same temperature again, but this one is 2 kilograms of ice to water at 10 degrees Celsius. Okay, so it's almost the same thing, but not exactly the same thing. That's why I want to solve the two of them at the same time, so that we will get what we're supposed to get there. Okay, so I'll first of all solve what we solve at the first one, which is changing this 2 kilograms of ice to water. First, changing it to water. So I will write quantity of ice, quantity of heat to change 2 kilograms. These 2 kilograms of ice to water. We have solved it in the other question, and you use the formula H, which stands for quantity of heat, is equals to ml, where H, I say, stands for the quantity of heat, M will stand for the mass, and L stands for latent heat. I want us to see what to solve in the first question. Okay, so it will be H is equals to M. What is the mass of the ice we are talking of? It is 2 kilograms. So I write 2 here times what's the latent heat of fusion of ice given to us? It is 3.36 times 10 raised to power 5. So times 3.36 times 10 raised to power 5. Okay. What do I do again? I continue. I say H is equals to 2 times 3.36 times 10 raised to power 5 means what? It simply means 3 again, 6, 0, 0. Yes, that's what it means. It means this number times 100,000, which will give us this. If you use a calculator, you need to give us this. If I go further to evaluate, I'll have something like this. H is equals to 2 times this will give us what? That wastes now time. Let's evaluate it. Let's calculate. 2 times 33600 give us 67,200. It gives us 67,200 joules. Okay, 67,200 joules. Which is, this is the quantity of heat that is required to melt first, to melt this 2 kilograms of ice, to change it from being ice, to melt it to water. This is the quantity of heat that is required to melt it to water. Now, which means now, this ice now, this 2 kilograms of ice is now melted to water with this quantity of heat. But the temperature is still at the same temperature of melting ice, which is 0 degrees centigrade. Temperature has not been increased. It's just melted to water. You know, sometimes you bring out ice and you block ice, you melt it. That you bring out ice, block ice, that is ice cube. You find out that when the ice started melting, the temperature, if you use thermometer, check it, you find out that the temperature still remains the same. It has not started increasing. Yes, the ice has started gaining heat from the surroundings and started melting, but the temperature still remains the same. Why? Because the latent heat is still working. The latent heat is still working on changing the ice to water at the same temperature. Okay? So now we have melted this 2 kilograms of ice to water at the same temperature, which is temperature of melting ice, which is 0 degrees Celsius. Now we'll go further to solve again, because they say at 10 degrees Celsius, what we do now is to increase the temperature of this melted ice, because we have melted it now to water. Now increase the temperature of it now to 10 degrees Celsius. Let's do it this side. Let's do it this side. So I'll now say, I'll write here quantity of heat. I'll write here quantity of heat required to raise the temperature of 2 kilograms of water, because we have melted ice now to water, of water from 0 degrees Celsius to 10 degrees Celsius is, let's solve this one now. We want to now increase the temperature of this ice that is melted to water. Now I want to increase the temperature from 0 degrees Celsius now to 10 degrees Celsius. So this one now does not involve latent heat. Rather, it involves specific heat capacity. So the formula we are going to use to solve it now will be H, which stands for quantity of heat, is equals to what? MC theta. No more H equals to ML. Now H equals to MC theta, because we are talking of increase in temperature. This formula goes with increase in temperature, while this formula goes with at the same temperature. No increase in temperature, at the same temperature. This one goes for anytime we have increase or decrease in temperature, but this one goes for at the same temperature, no increase, no decrease. Okay, let's continue. So H, we stand for the quantity of heat now, is equals to M, is still the same 2 kilograms of ice that is melted to water. So I'll write here 2. And now substitute these values into this formula. Okay, put my times. There's times here. C, what is C? C is simply the specific heat capacity of water, and they give it to us as 4200. So I write 4200 here times, that's the times here. Theta, that is temperature change. Now what is the temperature change? The temperature change we are trying to change now is from 0 to 10. We want to change it from 0 to 10. So 0 is the theta 1, while 10 is the theta 2. And we normally say theta 2 minus theta 1. So I write it now. 10 minus 0. Okay, theta 2 minus theta 1. Which will give us, if I evaluate, I have our H to be equals to 2 times 4200 gives us 8400 times 10 minus 0 is 10. Finally, the quantity of heat that is required to raise the temperature of these 2 kilograms of water from 0 degrees Celsius to 10 degrees Celsius is, I write it, is equals to what? 8400 times 10. Simply, you just add 1 0 here, it becomes 84000. This is the quantity of heat that is required to melt these 2 kilograms of ice from ice to water, and this is the quantity of heat that is required to raise the temperature after it has been melted from ice to water, to raise the temperature from that water from 0 degrees Celsius to 10 degrees Celsius. but the question says, what quantity of heat will be necessary to change 2 kilograms of ice to water at 10 degrees Celsius, which is the total quantity of heat that is needed both to melt it from ice to water and to raise the temperature from 0 degrees Celsius to 10 degrees Celsius. Yes, the total heat required is what the question wants us to give. So what we do? We simply say this plus this give us the total heat. So we say total heat here is equals to total heat required is equals to this number. Let me clean this one. Equals to 67200 plus this number 84000 give us equals to what? Final equals to what? Let's calculate it. It will be 67200 plus 84000 give us 151,200. Okay, so I write it down. Total energy necessary 151,200 joules. Answer. Yes, we have come to the end of this question, and we have obtained our total heat that is required both to melt these 2 kilograms of ice from ice to water at 0 degrees Celsius, and also to increase the temperature from that 0 degrees Celsius to 10 degrees Celsius. We have obtained the total heat to be 151,200 joules. So in this lesson today, we have learned how to melt a solid to a liquid that change in temperature, and also how to increase the temperature of the melted solid to a certain temperature. Yes, we have learned how to do both of them in this lesson. I hope you understand.